Welcome to the last section in chapter 3. Today we're going to be talking about parallel and perpendicular lines. And this is actually all a review from things you've done in algebra. Let's start by reviewing how you find the slope from 2 points. So remember, to find the slope from 2 points, you do y2 minus y1 divided by x2 minus x1. So you do the y's over the x's. And when you have a graph, you can do the same concept, but instead of having to write out the ordered pairs and subtract, you can also find this by doing rise over run. Remember that your y values are your up and down, your y-axis, so that's your rise, and your x-axis is left, right, so that's your run. So both of these would give you the same answer. Whether you use 2 points or you look at the graph, you'll get the same slope. Now, when we're talking about parallel and perpendicular lines, there's a special relationship with their slopes. So when you have 2 parallel lines, the slopes are the same. When you have 2 perpendicular lines, the slopes are opposite reciprocals. So opposite reciprocals has 2 parts. Opposite means one's going to be positive and one's going to be negative. Reciprocals, remember, is when you have a fraction and you switch the numerator and the denominator. So, for example, if I have 2 parallel lines, if one is a third, the other would be a third. So that's my and sign. For perpendicular lines, if one of mine was a third, the other one would have to be negative because a third's positive, and then the reciprocal, so 3 over 1, which would be 3. So let's use these concepts to figure out if lines are parallel, perpendicular, or maybe neither. So in this example, we need to decide which of these lines are parallel and which are perpendicular. So first thing we need to do is find the slope of each line. Since they're already graphed, we can just count the rise over run. So if we're looking at the blue line, it already has some dots marked for us, so we can just see it's a rise of 1 and then a run of 1, 2, 3. So the slope of this line would be a positive 1 over 3. The red line is a rise of 1 and then a run of 2 between those 2 points. So that'd be a slope of 1/2. The green one would be a rise of 1 and a run of 2, so that would also be 1/2. And then if we look at the purple line, if we're going between these 2 points, the -3, 2 and the -2, 0, you always go from left to right when you're finding the slope. So this time you're going down 2 over 1. So this slope would be -2 over 1, or just -2. So if we're looking at these, the 2 that are parallel would have the same slope. So that would be line B and line C. So line B is parallel to line C. Perpendicular would have to have opposite reciprocal slopes. So the opposite would be the -2 here is opposite sign of 1/3, 1/2, and 1/2. But then reciprocal, -2 would be the reciprocal of 1/2. So it turns out D is actually perpendicular to both B and C because it has the opposite reciprocal slope to both of those. A is neither parallel nor perpendicular to any of the other lines on the graph. Okay, another thing we need to review is the different types of equations of lines. So the first one is slope-intercept. So slope-intercept is when you have y equals mx plus b. Remember that m is your slope and b is the y-intercept. Then we have point slope form, which is y minus y1 equals m times x minus x1. So m is still the slope, And the point y1, x1 is a point on the plane, or on the graph, I'm sorry. X1, okay, the point x1, y1 is a point on the graph. Then we have standard form, which is ax plus by equals c. And you have to actually solve this for y if it's in standard form in order to figure out the slope and the y-intercept. So this one is the least useful, but it is one that you need to know. So we're going to do some examples with parallel and perpendicular lines using some of those forms of equations. So we need to write the equation of a line passing through the point -1, 1 that is parallel to the line y equals 2x minus 3. So parallel means that it needs to have the same slope. So we need to figure out what's the slope of y equals 2x minus 3. So the slope is this m. It's what comes before the x. Now we do not need to worry about the y-intercept when we're going parallel or perpendicular. It doesn't matter. We just need to worry about slope. So I need to have a slope of 2 that goes through the point -1, 1. So if I have a slope in a point, I need to start in point slope form, and then I can write it either stay in point slope form or change it to slope intercept form. So remember, point slope form that we just said is y minus y1. Let me get rid of that dot there. Oops, too much. So y minus y1 equals m times x minus x1. So I'd have y minus my y1, which would be 1, equals the slope, which is 2, times x minus x1, which would be -1. So that'll change to a plus. Oops. So I'd have y minus 1 equals 2 times x plus 1. So if they said to write my answer in point slope form, this would be the answer. Now, oftentimes they want you to change it into slope intercept form. So I need to get that y by itself. So I'd start by distributing the 2, and then I'd add the 1. So this would be the answer in slope intercept form. So depending on what it asks, these two would be your. So what we're going to do next is graph both of them in order to show that they are parallel. So we need to do a quick refresher on how we graph. So let's write down those two equations. Now I'm going to do the slope intercept form. So we have y equals 2x minus 3 and y equals 2x plus 3. Those are the two that we need to graph. So remember, when you're graphing lines, you start with the y-intercept. So if we're looking at the first one, the y-intercept would be -3. So I'm going to go down here to -3. And then the slope is 2. So I'd go up 2 over 1. And then I'm going to connect those with a line. So I'm going to do another up 2 over 1 to try to make this as nice as possible. And I don't know why it's so wavy, but that's what it is. So that would be the 2x minus 3. So now if I graph y equals 2x plus 3, my y-intercept is positive 3, 1, 2, 3. And then I'd go up 2 over 1, up 2 over 1, up 2 over 1, and connect those. So if these were straight lines instead of wavy, you can see that these are parallel. So that's how you can verify that what you did was correct. Now let's look at an example where we need to go perpendicular. So remember, perpendicular is opposite reciprocal slope. Well, this is in standard form, so I actually need to solve this for y before I can even find my slope and then do the opposite reciprocal of it. So if I solve for y, I'm going to subtract that 2x to the other side. So y equals -2x. It's like it just doesn't want to do an equal sign. There we go. Plus 2. So the slope of this line is -2x. So perpendicular, I need to do the opposite reciprocal. So it's going to be a positive 1/2. And I need to go through the point 2, 3. So I would start with doing y minus the y value of the point equals the slope times x minus the x value of the point. So if I was supposed to put it in point slope form, I would actually be done. If they want me to write it in slope intercept form, I need to get the y by itself. So I'm going to distribute the 1/2, and then I'm going to add 3. So y would equal 1/2 x plus 2. So that would be my answer in slope intercept form. So now we're going to graph again these two lines to show that they are perpendicular. So I'm going to graph them both in slope intercept form. So I have y equals negative 2x plus 2 and y equals 1/2 x plus 2. Now, it is a total coincidence that these have the same y-intercept. That normally doesn't happen. So I just want to note that that is a coincidence. But it does mean they're both going to have a y-intercept of 2. Now, my first one, from that, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and connect those. Then my other one, from that y-intercept of 2, I'm going to go up 1 over 2. Up 1 over 2, up 1 over 2. So as you can tell, when I connect those, these are indeed perpendicular. They make a right angle right there. All right, I do want to go back really quick and go over, we did some finding parallel and perpendicular lines if we're given a graph. Let's quickly recap if you're given ordered pairs instead. So you're still looking for same slope or opposite reciprocal slope. But now we need to use that slope formula. So the y2 minus y1 over x2 minus x1. So if I'm looking at line 1, so this would be my x1, y1, x2, y2. So I'd have, I'm going to put L1. So I've got 9 minus 5 over negative 8 minus 10. So it's going to be 4 over negative 18. And you always want to simplify if you can. So I can divide these both by 2. So it's going to be negative 2/9. And then if I look at line 2, I have negative 6 minus negative 4 over 11 minus 2. So this would become plus. So negative 6 plus 4 would be negative 2 over 9. So these have the same slope. So these lines would be parallel. All right, let me know if you have